problem. Open Air Waste Management is designing a rectangular construction dumpster that will be twice as long as it is wide, and it must hold 12 yards cubed of debris. Find the dimensions of the dumpster that will minimize the surface area. Okay, so we're going to assume it's a regular open top dumpster. Which means it looks like this, with the top open. So it's going to have a bottom, it's going to have 4 sides. We don't know any of these sides, so let's do this. This will be the length, this will be the width, and this will be the height. What does it tell us? It says that twice as long as it is wide. So since this will be the width and this is the length, so it's going to be, length is 2 times W, twice as long as it is wide. What else did they tell us? Must hold 13 yards cubed. That's a volume dimension. So volume on a rectangular prism like this is length times width times height. I have length in terms of width here, so let's make a substitution. And when we simplify, it's 2W squared times H. And the given information is that this value has to be equal to 12 yards cubed. Okay. They want us to find the dimensions that will minimize surface area. Surface area is the sum of all the faces of a figure. So the sum of the measurements of the area of all the sides and the bottom. So surface area will be equal to the area of the bottom, which is going to be 2W by W, plus the front and back. So the front and back, there are 2 of them that are going to be H by 2W, plus the left and right sides. Area of the left and right is H times W, but there are 2 of those, so it's 2 of these H times W. Let's go ahead and simplify this up. So it's going to be 2W squared plus 4HW and 2HW, that's 6HW. Is going to be equal to my surface area. Now, again, I've got too many variables, which means I'm going to have to go back up to this constraint equation and solve it for one of the letters. So let's solve it for H. If we divide the 2W squared over to the other side, let's not do it this way. Let's put the H here. H will be equal to 12 over 2W squared, which reduces to 6 over W squared. All right, that means I can replace this H with 6 over W squared. Which means we can multiply the 6's together and reduce these W's by 1. Okay, now we have an equation that we can go ahead and take the derivative so we can find the max-min value. So derivative of surface area will be 2 times 2 is 4W plus, remember when we deal with 36 over W, we're going to think of it as 36 times W to the negative 1 power, so that when we do the derivative, negative 1 times 36 is negative 36. And then W to the negative 1 minus 1, negative 1 minus 1 is negative 2, which means in order to have a positive exponent, it has to go back down into the denominator. Now, in this instance, we don't exist when W is 0, which doesn't make sense in the context of our problem anyway, because we can't have 0 width. So that would be one of the critical values that we're going to ignore because it doesn't make sense. And we're going to go ahead and set this first derivative equal to, I don't need a plus minus, I can just use minus. Set that equal to 0 to get any other critical values. If we multiply both sides by W squared, 4W times W squared is 4W cubed, and then W squared times 36 over W squared means they would cancel, which leaves us with minus 36, and 0 times anything is 0. So let's go ahead and add the 36, divide by the 4, so W cubed is 9, so to figure out what W is, we'll take the cube root of both sides, cube root of 9 is approximately 2.08. Well, we're talking yards here, so this would be in yards. So then possibly the maximum surface area will occur when the width is 2.08. Let's go ahead and use our first derivative test to figure out if it is local max or local min. We're going to go ahead and use maybe 1 and 3 for test numbers in our first derivative. So, and it'll be 4 times
1 plus negative 36 over 1 squared. This is negative. This is like negative 32, which means it's decreasing on the left. If we put a 3 in, 4 times 3 minus 36 over 3 squared would be 12. Minus 36 over 9 would be 4. 12 minus 4 will be 8. This is positive, which means it's increasing on the right side. So we went from decreasing to increasing, which means there's going to be a local min at 2.08. So 2.08 is going to produce our minimum surface area. Let's go ahead then and figure out what the length and width are going to be. So the length was 2w, so length will be 2 times 2.08, which will be 4.16, and this is in yards. And then as far as the width is concerned, excuse me, we have the width. As far as the height is concerned, the height came from this up here, which is 6 divided by w squared. So height will be equal to 6 over 2.08 squared, which is approximately 1.39 yards. So then our rectangular dumpster will be length 4.16 yards, by width 2.08 yards, by height 1.39 yards. Okay. Read the problem, made a picture, labeled it with what we could get from information in the problem. The length is twice as long as it is wide, so L is 2 W's. Didn't have anything directly from H, but it did give us a constraint, must hold 12 yards cubed. So we went ahead and wrote the volume formula. Volume is length times width times height. We could get the L in terms of W, but we had to do some work here. So H in terms of W means H would be equal to 12 divided by 2w squared, and that simplified to 6 over w squared. This is good. So we want to maximize surface area. So we wrote down our formula for surface area and replaced all the letters that weren't w with something in terms of w and simplified. Found the first derivative, so we could do the first derivative test to find local max min. Found critical values of 0 and 2.08. 0 doesn't make sense in the context of the problem. So we just tested on either side of 2.08 to discover, yeah, it's a local min there, and then went back to our other equations for L equals and H equals, substitute in the 2.08 for W, and got the rest of the dimensions.